What's up?
So for C++, how do I run it on Mac? I downloaded C-Lion.
Mm-hmm.
Do I need to connect a terminal to it?
No. So how do you run C-Line? You create a new project, file, new project. Once you create the new project, just give it some name, use the default settings, and that will create a project like this, right? And then by default, it will create a main CPP file. You just double click this to open it. You look at the tab, main CPP. It should already have at least this, right? Add the include IO stream, add using namespace std, and then test it by just doing a cout, something like this, right? And then to run the program, on top, there's this little triangle, right? You click this thing, and then the program runs underneath. If there's any errors, it'll show them, semicolon, run again, and it runs right here. So no need for a terminal for C-Line. If you're using something else, you might need to, but no, not on C-Line. Any other questions? We're good? Okay, so I am starting with week 4 officially. So week 4, we're going to talk about repetition. If you've done it in any other programming languages, it's pretty much the same. I just want to point out a couple of things before we get into that. And that is, in addition to your comments on top of your programs, right? Remember, these have to be there. If they're not there, I'm taking off at least 30% off your grade. And if you don't show me how the program ran, I'm taking off at least another 30%. Okay, another thing to watch out for is the indentation. Okay, I don't want to see, well, C-Line kind of prevents me from doing this, but I don't want to see this kind of stuff. All right, cout, hi. Right, what's wrong with this? The indentation, right? Grab this thing, tab it. Okay, if you're going to have an if, I don't know, 1 is equal to 1, right? Curly brackets. Don't go and start writing the code here, because I will take points off for this stuff. Okay, makes your code hard to read. I don't want to deal with it. I don't even ever want to see this kind of a code written. So if I see something like this, you're going to get some points docked off, and I'm going to say fix your indentation. Okay, how do you fix the indentation? Under week 1, there is a proper indentation link, right? This link right here, if you click it, there is a picture in there that I have posted that shows you basically this kind of stuff. Okay, if you have a main, anything that's within the main is indented 4 spaces, right? Consistently, if you have int here, 4 spaces, you're not going to have the if indented. Only whatever's inside of the if is indented. Okay, so this is the format that I would like you to follow, and if you don't follow it, you'll pay the price. Okay, and it's not just for me to be mean or whatever. It's just, it will make your life easier when you write bigger programs. It's easier to read. Okay, I cannot read codes that is not properly indented. I refuse to. Okay, so proper indentation. Another thing is, be careful so that your lines, your code doesn't get really long, right? Don't have something that's like goes more than 80 characters wide, and you can see how many characters you have by looking at this thing on the bottom, right? So every time I add a space, that increases how many characters I have per line. No more than 80. Okay, anything more than 80 is hard to read. It exceeds the width of the screen, and you're gonna have to scroll off the window. It's hard to read, so don't do it. Okay, it's not a rule fixed like in stone. So there's sometimes like that Zodiac program, which you have to do a whole bunch of ifs and elses. Where was that thing? Let's see, maybe week 3. Week 1, not week 3. Right? This astrology program would be an example of where you might, feel tempted to break that rule, and that's okay. Right? There's a sample code in there that you can see that, there's an if, and there's a couple of ands in there, and there's an or also. So if you have to bunch up a whole bunch of these kind of logical statements on the same line, that would be the one exception to this rule. Okay? But anything else, try to keep it narrow. The narrower, the better. Even this 80 character wide is kind of wide, so the narrower, the better. Okay? If you can fit it in like 40, 50 lines, columns or characters, perfect. Okay? So, any questions about any of the assignments so far? Anything at all? We're good? Positive? Okay, I'll take your word for it. So, what we're going to do is we're going to start talking about stuff in week 4, which is loops. Okay, so I guess the example that I would do is remember how we had a situation where you have some kind of a variable age, right? And the user enters some kind of an age, right? So enter age. And you want to make sure that they enter a good age. Okay, and up to this point, I kind of told you, okay, use an if. So if my age is less than 0, or my age is bigger than 123, right? You want to give the user some kind of a message like, oh, this is invalid input, cout, invalid age, and enter value between 0 to 123, something like that. Okay? And then you do another cin in there, and you ask for another age, which is fine if the user does not go in there and give you bad age a couple of times in a row. So I have enter age, right? I'm going to go in there and give it a -9. So it's going to tell me invalid age, please enter a value between 0 and 123. But I really suck at this, so I'm going to go and give it another negative value, and the program continues. So what we want to do is we want to make sure that the user stays in that keeps getting the same question and input prompt until they get it right. So what I'm going to do is, instead of having an if in here, I'm just going to change this thing to while. Okay? Just like most other programming languages, if you've taken Python, same way. Okay, so how is this going to work differently? Well, I run the program, I give it a negative age, no good, then I give it another negative age, and it's going to keep asking me this question until I finally give it a good value. Right? Okay, here you go, 12. And then it stops. Okay? So this is an example of input validation. Input validation, that's the real input validation using a while loop. Okay, so the while keeps repeating until the user enters a valid or a good value. Okay, so what's a while? It's just like an if that repeats over and over and over and over. Okay, it could have one condition, it could have multiple conditions. So let's test this thing with just less than 0, right? So if age is less than 0, I'm going to run the program again. Right? -9, -9, -9. I give it a good one, and then it takes it. Okay? And how is that different from an if? Well, the if only happens one time. Right? I run this thing with an if. I give it a -9, give it another -9, and then it stops. Okay? So that's it. That is a loop. So let me go change back this to a while. Okay? So it's just like an if that happens until the conditions are true. Okay? So that's one example. So let's say, so that's one purpose of a loop, or having your code repeat something many times. Another purpose will be to maybe show a list of numbers, right? So let's say I want to go and I want to do, let me show you some other loops. So first what I'm going to do is I'm going to take this out because I don't want to be asking myself to enter a value again. Okay, so let's say I want to show the numbers from 0 to 100, right? In increments of 1, right? So I want to show 1, 2, 3, all the way to 100. Okay? What do I do? Bless you. So if you know how many how many numbers you want to show, right? If you know the start, the end, and the increment, this is a good candidate for a for loop. Okay, so if you know when it starts, if you know where it ends, use a for loop. Okay, so for example, it goes like this: for int I is equal to 1. I want this thing to start at 1. So my start is, this is my start, right? This is my end, and then my increment is 1. If I can spell it. Okay, so it starts at 1. I'm making a variable I, which is equal to 1. Then I'm going to tell it I'm going to tell it go on, start at 1, go on while I is less than or equal to 100, and then tell it that I is equal to I plus 1. I plus 1. Okay? So then I'm going to go in there, I'm going to do the curly brackets, I'm going to do a cout I, and then I'm going to put a little comma after it, and I'm just going to let it do its magic. Okay? So this is your start, then this is your stop, and I guess the increment is this. Okay? So start, stop, increment. If I run this thing, forget the age, right? You're going to see that it shows you 100 numbers. We're kind of running out of screen, but there you go. 100 numbers from 1 to 100. Okay? Very, very quickly. Okay? So, let's say I wanted to go from 1 to 10 in increments of 1. I just change, this stays as 1. I'm going to change this to 10. I'm going to run the program. I'm going to take out this age business here too. Let me take this out one more time. All right, there you go. And then it shows you the numbers from 1 to 10 separated by a little comma. Okay? Let's say I want this thing to, so this is 1. Let's do cout and L. Right? Let's say I want my loop to start at 10, or let's do still at 1. I want it to go to 10, but I don't want it to go in increments of 1. I can go and tell it, okay, increments of 2. Okay, I'll run it again, and now you see 1, 3, 5, 7, 9. Okay? Another way to write this thing on top here is increment. You can do I plus plus. You can also do I plus equals 1. Right? So you could write this line right here either as this or as this, whatever your heart's desires. So personally, I will do it this way, bless you, because that's the shortest. Okay. This was not something that you could use in Python, but it is in C++, it is in C, it's also in Java, and a lot of other languages. So take advantage of it. It's shorter, it's easier. I'm actually surprised that Python didn't have this in the language, since they're lazy about every other thing. So those are the increments. So the increments is 1 here, Here the increment is 2. Okay. What else? Let's go. I'm going to grab this thing. I'm going to copy it, paste. Let's say I want to go backwards. So I want this thing to start at 10, right? I want it to go while this thing is greater than or equal to 0. I want it to go all the way to the 0. And then I'm going to tell it go backwards, -1. Okay, so this one increment is -1. So you can also write this thing as I minus minus, and you can also write it as I minus equals 1. Okay, either way works. Which way would I do it? I'll do it with the minus minus if I can. I'll go with the shortest possible way. All right, so I'll run this thing again, and there you go. Now it's going backwards, 10, 9, 8, 7, all the way to 0. Okay. So again, if you know how many times the thing is going to happen, if you know where it starts, if you know where it stops, if you know the increment or the decrement, then it works fine. Okay. What else? So you could also have the user type in how many times they want this thing to happen. Right? I can say, all right, so a loop that happens as many times as the user wants to. Right? So I do something like, I don't know, let's say I'm going to have an int stop, right? And let's say I'm going to have an int start, and I'm going to say int increment or step. I'm going to call this step. Okay? So step is, I'm going to make it equal to 1. The start, I'm going to make it equal to 0. And the stop is what the user is going to give me. Okay, so I'm going to say cout, how many times would you like to repeat the loop? And then I do a cin stop, and then I just write my loop for int I is equal to 0. And by the way, this I is just a variable I make up. I can call it whatever I want. Let's call it x, right? Int x is equal to 0, while x is less than or equal to stop, and then x plus plus, and, or, right, let's just erase this, the step, okay? Then I go in there, and I show you basically the same thing as before. Copy this, paste it there, make it an x. Okay, one thing, notice if I try to run the program like this, it doesn't know what I is, right? Because I have been defining what I is for inside of the for loop, right? See, I'm declaring I here, I'm declaring I here, I'm declaring I here. If I try to use I like outside of the loop, right? So let's try to do this. Cout I equals I and L. Right? Notice how cline already kind of marks it red. If I try to run my program, run it, you're going to see that error again. Right? Cout I blah blah blah. Use of undeclared identifier I. Okay? So this is, I guess, your first introduction to what a local variable is. Okay? So the variable I, so you cannot do this. Alright, this is bad. Alright, because the variable I is declared inside of the for loop, which means that I is local or can be used only inside or local, only in local to the for loop. Okay? In other words, I declare the I for this loop, I can only use it inside of the curly brackets of this loop. Okay? And remember, if I only have only one statement, do you remember how we had an if? If you have, for example, if you have if age, let's go this. Age. And age. Okay, so if I have if age is greater than 0, I can do a cout positive or something. Okay. I can also use curly brackets around this thing. right? But I don't have to. If I have a single statement inside of an if, I don't need the curly brackets. Same thing with the for loop. If I have a single statement inside of my for loop, I don't need the curly brackets. I can go in there and I can erase this, I can erase this, I can run my program and it will work the same exact way. Okay? So a single statement, a single program line, or a single line of code inside of a for loop does not need curly brackets, but you know, for consistency's sake, go ahead and put curly brackets on everything if you want. Okay, so again, what is a local variable? A local variable is a variable that can be used only where it was declared. Okay, it can only be seen where it was declared, it can only be changed where it was declared. If I try to use it somewhere else, like here, it doesn't know what I is because it's local to one of those loops up there. Okay, just like the X here. So I'm gonna go in there, make it an X, okay, and let's see how this works. Maybe I should put a new line there. Alright, how many times would you like to repeat the loop? 4 times. There you go, 0, 1, 2, 3, 4. Oh wait, it happened one more time than I needed to, so I'm going there, change this to less than, run again. How many times do I want to repeat the loop? 4 times. Now it goes 0, 1, 2, 3. I can also change this to 1. Make this greater than or less than or equal to, run it 4 times, and then it goes 1, 2, 3, 4. Make sense? Any questions? All got it? Okay. So again, I know how many times the loop is going to happen. Maybe the user decides that. Maybe I have some idea in advance. I know what the step is. I know by how much the numbers are going to increase. I know where it starts. I know where it stops. So that's a candidate for a for loop. And one more thing. So let's say, see how so far I have been showing like a little comma at the end of this thing? How can I do this so that it doesn't show me that comma? I can use an if. Okay, so basically, there's a couple ways to do it. One way to do it is, so let's say I don't want to show the last comma. Okay, that's what I don't want. So 2 ways. So I'm going to grab this thing here, copy it, throw it under. One way will be is if I'm going to add an if in here. I'm going to say if my x is less than stop. Right? I'm going to do it this way. Okay? And else, or I can just do if my x is equal to stop, then I'm going to show this thing like that. And instead of a comma, I'm going to put an endl. Okay? Run the program again. How many times do I want to do this? 4 times. Maybe I should have done let me do a cout endl here. One more time. Run it. So how many times do I want to do this? 4 times. There you go. The first one has a comma included because we're always going to show a comma. And the second one shows you the first 3 with a comma, and then it shows you the last one without the comma. Yes? Alright, so that's one way to do this. And then another way to do this is I'm going to rewrite this whole thing. I'm going to grab this. Actually, let me grab this one here. The original. And what I'm going to do is, this time, let me change this variable. I'm going to make it like a z or something. Z. Just so you know, it's an arbitrary name that I choose. And I'm going to go in there. This is my z. What I'm going to do is I'm going to say, and I'm not going to declare the z inside of the loop. Okay, what I'm going to do is I'm just going to say, all right, z is equal to 1 here, and I'm going to declare it before the loop, int z, like that. Okay, what this will let me do is it will allow me to use the z afterwards. So what I'm going to do is I'm going to change this thing from less than or equal to just less than, right? So let's see how that works up to that point. So if I run it, I go and I tell it, okay, how many times do I want to do this? 4 times. You can see that this loop here, the one with the Z, right? It goes 0, 1, 2, 3, and then it doesn't show you the last one. What's going to be the last one? Let's try it here. C out, Z, and L. Okay, now it knows what the Z is. If I try to do this thing to the X, watch, if I do a C out X here, X, right? It doesn't know what X is because I declared the X inside of the loop, which means that I can only use the X inside of the loop. So I'm going to get rid of this here. Here I'm declaring the Z outside before the loop. I'm using it inside of the loop, then I'm using it outside of the loop. Let's see what the value of Z is when the loop is done. So I run it 4 times. There you go. Okay? So you should be able to kind of, have an idea, a very good idea of what I just showed you. So notice that the loop tells this thing to go from 1 to less than stop, right? So my stop value is 4. So without this thing here, 4, it goes 0, 1, 2, 3, right? So it goes to 3, it shows you the 3, and then what happens is it goes back to the, so it basically, there's like a circular thing that's happening, right? You start at the top curly bracket at 1, you show this thing, then you go back to the beginning, you check, you increase Z, right? So Z is initially 1. Okay, I show you the 1, then I go back to the beginning of the loop, right? I check then I increase Z plus, Z becomes 2, I check is 2 less than 4. Yes, I show you, then I do the second C out, now it shows you the 2, okay? Then as soon as I show the 2, I increase the Z, I do a Z plus, I'm at the end of the loop, right? I increase Z plus, so now it's a 3. I go and I check, is 3 less than 4? Yes, still is. Then I go in the loop, I show you the 3, so I show the 3. Then I go and I increase the Z plus, so now it's a 4. I go back to the beginning of the loop, is 4 less than 4? No, stops right here. Okay? So that's why this Z does not show up when we get to 4. Okay, if I wanted to show it, I can just do less than or equal to, and then it will show 4. And then what is it going to show me if I do it this way? With less than or equal and a 4. Go to 5. Okay? So let's run it. 4. All right? So keep in mind that the variable at the end of the loop will be incremented one more time. You're going to check to see if this is true. For 3 it is. For 4, when it's 4 is not less than 4. You end the loop and then you show the last 4 right here. Okay? Any questions? We got it? And of course we can make this thing go backwards. I can tell it start at 4 and then go back to 0. Right? Let's do that. So I'm going to go in there. I'm going to make another one. So I'm going to say here, grab this whole thing. Alright, so I'm going to start this thing at stop now. I'm going to tell it to go while this thing is greater than 0. And then I'm going to tell it go backwards. Right? So this is not going to include the 0. Why is it complaining? It's not at the end of the loop. Okay. Z minus. There you go. Okay? So now what is going to show me? If I enter 4, it's going to show me 4, 3, 2, 1, 0. Then when it gets to the 0, is 0 bigger than 0? No, it isn't. Exits the loop, and then it shows you the last 0 here. So I run it again. Oops. No semicolon inside of the loop. Oh, that's kind of important. So no semicolon at the last thing, and never put a semicolon at the end of the loop. Okay? Because of how annoying C++ is, it will not give you an error message. Okay? It's just not going to work. Alright? So first I'm going to run it so you can see how it works. Run this thing. So I want 4, 3, 2, 1, 0. Right? Maybe I don't want to go to the 0. Make it greater than 1. Right? Run it. 4, 4, 3, 2, 1. Okay? Now notice what happens if I put a semicolon at the end. Now some languages, like Python, if you do some kind of a thing that will mess up the loop, it will give you an error message. Not C++, right? When you put a semicolon at the end of the loop, we're actually calling this a do nothing loop. And the same thing happens to an if. If you put a semicolon at the end of an if, it's like you might as well do this. That's the effect of it, right? Why it's not a syntax error like 30 years in after the language was created? Don't ask me. It just isn't. Okay, it should be, right? So how many times do I want to repeat the loop? 4 times. Notice what happens to the last one. It's just not working the right way. Okay? Questions? So don't put semicolon at the end of a loop. Okay? Don't put a semicolon at the end of a for. Don't put a semicolon at the end of a while, right? If I go in there and I put a semicolon on this thing, that's also not going to work. Okay? If I have an if, right? Where's that if thing that I had somewhere in there? So if I have if, damn it. Oh no, it crashed. First time C-line crashes on me. Damn it. Reopen. I hope it saved it, at least. Otherwise, you're going to have to watch the video. All right, saved it. So, what else? Yeah, so if I have an if right here, right, and I put a semicolon at the end of the if, that will basically mess up the if, right? If I have a for loop and I put a semicolon at the end of the for loop, that will mess up my for loop. If I have a while, same kind of business, right? Don't put a semicolon or it won't work. So, okay, so this is, these are for loops. So you know how many times the thing is going to happen. You know where it starts, where it ends. You know the increment or the step. Then use a for loop. Okay, and all these that I showed you can be done using a while loop. Okay, so what I'm going to do is I'm going to rewrite all of these things that I did so far using while loops. Okay, so it will go, and I'm going to use different variables for them. I'm going to say, okay, so if this is your start, stop, increment, kind of messed it up. Let's call it step. Okay, I can do this with a while loop. So I'm going to say int j is equal to 1 while j is less than or equal to 10, and make sure there's no space in between these. Then in here I'm going to show you cout j with a little comma, and in here I'm going to say j is equal to j plus 1. Okay, so this is my start, this is my stop, and this is my step. So you can see that one is obviously a little bit shorter than the other one. They both do the same exact thing. So it is better code for you to use a for loop if you can. All right? Not that you cannot write anything that you could with a for loop using a while, but it's just better practice to use a for loop. If you know where it starts, it stops. Okay, so let's have a look at this thing, see if it works. I'm going to do an endl in there. Damn, that's unusual. Now I guess I'm going to have to rewrite the while loop. Damn it. Okay, so what I'm going to do is, this really sucks. I'm going to draw it in there. So one more time. Int j is equal to 1. This is my start. I'm going to be saving this thing now. It doesn't even save automatically. No, it does. Okay. While j is less than or equal to 10, and then cout j okay, and then do j plus plus, or j is equal to j plus 1. All right, so again, start, stop, step, and let me do another save again, cout, and L. Okay, so I'll run it again. And these first two, maybe I should put a J in there. Hold on. Instead of an NDL, I'm gonna do cout while save. All right. So this is your for loop in the beginning. Then you have your while loop underneath it. Basically the same exact thing. Okay, so that's one. I can rewrite this thing underneath it too. So I'm going to grab this thing, copy, throw it here. Okay, so this one was I plus 2. So j, I can do plus 2 here. Run it again. What's happening is I am redeclaring j, I believe, right here. So the error is I declared j already once here, and I'm trying to redeclare it again, right? And it actually tells you redefinition of j at line 52. This is line 52, so I just erase this. All right, try it again. And there you go, right? The for loop on top and the while loop underneath it. Any questions? Same, but different. Okay, so let's do another one. Grab this whole thing here, copy it. That's the step backwards. All right, so this time j starts at 10. J is greater than or equal to 0. All right, j is equal to j minus 1. All right, run it. And basically the same thing. Now it goes backwards. Okay? So basically anything that you do with a for loop can be done with a while, but there's some things like the input validation that I showed you in the beginning that you cannot do with a for loop. Okay? That's one. So while we're at this point, right, I can also make a loop that happens as many times as the user wants to using a while. So let me go in there and just write one of these here. Let's go with this one. So I'm going to rewrite this thing using a while. So z starts at 1. J stops at stop. Okay, and then it goes by +1. So I'm going to do j plus plus here. Okay, and if I run this thing, how many times do I want to repeat this? 4 times. And there you go. This is your for loop. This is your while loop. They both do the same thing. Okay? So what else? Now that we've done this, let's have a look. Oh, and there's a semicolon in here because that's why this thing is not working. All right, I had a semicolon here. That's why I was messing up here. Okay, so no semicolons after for, no semicolons after while. Okay, it makes it a do nothing loop. It does nothing, so don't do it. All right, so that leads me to creating a never-ending loop. Okay, so let's say I go in there and I do something like for int k is equal to 0, right? And I say while for k greater than 0, k plus plus. Okay? Cout k equals k and L. Save this thing. And one more time. So let's have a look at it. Starts at 0, create k is 0. Let's try to greater than or equal to 0. It's trying to sabotage me 4 times. There you go. That's a never-ending loop. Okay, so what's happening with the k? Let me stop it before it crashes again. All right, so k starts at 0, and I'm telling it go on while k is greater than 0. Well, greater than or equal to 0. And then I'm telling it just keep increasing your own value. And it will just keep doing this and keep doing this and keep doing this until forever. Until it runs out of memory, the operating system kills it, or the program crashes. All right, whichever one happens first. Okay, in fact, in one of the data, in the data structures for Java that I teach, I actually teach students how to do, well, basically tell you, okay, try to make a linked list and then insert as many links in the linked list to see when the computer runs out of memory. You have to put a whole bunch of them. Okay? In fact, we're already at 4 million, right? 4,355,000. So that's a lot of times that it went through the loop in that little time span. Okay. So never-ending loop. Be careful. It can happen to you. And it happens to the best of us. Sometimes you make a loop and you forget that maybe you copy-pasted something, or it doesn't, you didn't think about it, and it just goes on forever. Okay, so let me just undo this and tell you that this is a never-ending loop. Okay, so I'm just going to comment it out so we don't want to see it again. There is another way to make a never-ending loop. Okay, so this is here now as this is a loop that goes on forever until the user enters a specific value. Forget your updates. Okay, so I'm gonna do this. I'm gonna say, all right, while I can do something like 1 is equal to 1, right? So the loop, the while loop will go on until the condition is true, right? And this condition that I created here will always be true. 1 is always equal to 1 as far as the computer knows. Another way to write this is I can just say true, just like that. Okay? So that's a never-ending loop that I created right there. Okay? But what I'm going to do is I'm going to find a way to stop this thing. So let's say it's a loop. So the loop should stop when user enters 0. Okay, it could be whatever value I want. So let's say I'm going to make a variable here, int value. Okay, so I'm going to say cout enter 0 to stop, and cin value. Okay, and if I just run it like this, it won't really do the magic. Save it again before it crashes. Okay, so I go in there. This is the first one, 3. Okay, enter 0 to stop. 1, 2, -1, -2, 0. Doesn't stop it, right? Nothing's gonna stop this thing because I didn't put what I need to put in there. So I'm gonna go in there. Are you trying to crash on me again? Damn it. I've never had CLAN give me this many bugs ever. Come on. Work with me. Don't buy a Mac. Just kidding. Damn it. Oh, there you go. There's a terminate. Yes, terminate this. Okay. So the next thing I'm going to do is I'm going to add an if in there. So if my value is equal to 0, I'm going to do a break. Okay, and what is the purpose of the break? Break stops the loop here. Okay, so let's run it again. Okay, who cares how many times the loop? Now it's asking me enter 0 to stop, so 1, -1, 2, -2, 0, and it stops. Okay, now let's do it another way. Let's do something else. So I'm going to go in there, I'm going to do a cout. Oh, actually, let's do another one. if value is equal to 1, continue. Continue. Okay, so what continue does is continue makes the loop resume from the top curly bracket, I guess, if you want to call it that. Okay, and then, so I'm going to show you. So I'll enter 0 to stop, so I'm going to give it a 1, 2, 3. So if I give it a 1, right, I give it a 1, it's not a 0, so we don't break it. We go to the 1, value is equal to 1, and tells it continue. That makes it jump back to line 133. Okay, so top curly brackets, and then it resumes from the beginning. Okay, so still, really, you haven't seen any difference. I go 0, stops. Okay, but let's say I have an output here. I say, all right, cout hello world. So my question to you is, when will this show up? For what values of value? I'm very creative with variable names. Okay, so for what values will this message show up? No, the indentation doesn't matter. Right? So basically, I have one if this is true, this is going to happen. I have another if this is true, this is going to happen. And then I have a cout, which is outside of these ifs, right? But it is inside of the loop, so it should show up. But my question is, for what values of this variable would this message show up?
Anything that's not 0 or 1.
Correct. Okay. So if I give it a 0, we stop, we exit here, right? And that's it. So I can have a cout here, hi, right? So this one here, if I enter a 0, is this going to show up? No, because the loop exit here, right? So if I enter 0, this does not show. Okay? And here, if I entered 0 or 1, the below does not show. Okay? Make sense? Got it? So continue makes the loop resume from the beginning. Even though we might have a whole bunch of code underneath it, as soon as you hit the continue, you go back to the beginning of the loop. Okay? You could have a whole bunch of things underneath the break. As soon as you hit the break, you're out of the loop at that point. Okay? So now you know about break, now you know about continue, you know about a never-ending loop. Okay? Any questions? You know not to put semicolons after a loop, okay, because that messes it up. Okay? All right. What else? So that's pretty much all I want to tell you about loops. Now let's do some practical applications of these things. So what I'll do is I'll just go and look at the assignments for today. So first of all, I have P19 as just some examples. All right, there's a couple of pictures underneath here. Okay, make sure that when you type up the examples, you run them, copy, paste to your output, put it at the bottom of your code. Same rules apply for your sample programs as for everything else. Make sure you type up all the comments because they have a meaning. You know, they explain to you how things are working. And I have 2 sample programs, this one and then the other one. Type them up, and there's some examples in there for with a for and a while and break and continue with some explanations. So that's the first one. Yeah. Canvas does let you submit more than one file. So if I go, watch, I'm going to go to students. Yeah. If I go to student view, and let's say I'm going to week 4, all right, I'm going to go to that first one, 19. All right, and I'm a student. I'm going to submit an assignment. In here, you can add another file. Yeah, you can do multiple files. Where Canvas sucks is that if you try to upload one file and then let's say you finished one sample program, you want to submit it, and then you want to go home and do the rest of them. If you submit the second one, then your first one is going to be hidden from you, which is the stupidest thing ever. So it hides your own work from you. Why? I don't know. Because whoever's developing, Canvas is just inept software developer. So going back, so yeah, you can submit multiple files in there. Please don't submit zip files or whatever. Just unless I tell you submit a zip file, which is not going to happen in this class. Just put all the different files in there separate, and if you can do them all in one submission, that way you have record of your own work. Otherwise, it'll hide it from you, because that's what Canvas wants to do. All right, so this is 19. Going to the next one. Leave. Okay, so this one here talks about kilograms and pounds. You have a bunch of kilograms on the left and a bunch of pounds on the right. Right. So I guess the example that I can give you is, let's say, let's do some currency conversion. All right. So pick a currency. Everybody wants the euro. All right, euro. Euro is 1.1 US dollar. Okay, actually the euro is going up with respect to the dollar, in case you don't know. Not that you care. Okay, and that's what this thing tells you. Also, the dollar, the gold is going up in terms of dollars. So yeah, and yeah. Anyway, so going back to the euro thing, so 1 euro is 1.19 US dollar. Okay, so I'm going to write this thing here somewhere. So this is your P20 hint. Okay, so I have 1 euro is equal to 1.19 US dollars. Okay, so what I'm going to do is, let's say I want to show the euros and dollar equivalency for euros from 1 to, I don't know, 10. Okay, I'm not going to go, all right, let's do 100, whatever. Okay, so is this going to be a for loop or a while loop? For, because I know where it starts, I know where it ends, right? And let's say I want to do an increments of 10. All right, so main thing is I know where it starts, I know where it ends, and yeah, I also know the increments. So I'm going to show you 1, 10, 20, etc. until I get to 100. So for let's make a meaningful variable name. So I'm going to say euro, or let's make an int euro is equal to 1, and until we get to euro is less than or equal to 100. And then we're going to say euro plus equals 10, right? That's my increment of 10. Another way to do this, if you want to, is you say euro is equal to euro plus 10. Whatever you feel comfortable with, okay? Even though one might be a little shorter. Okay, so let's go with this because maybe that's what makes more sense when you're first starting with programming. I'm just telling it euro, you're equal to your old value plus 10. Okay, so the first thing I'm going to do is I'm going to put a little label here. I'm going to say, all right, euro, and this is what you should do. Remember, write a couple lines of code, run the program, see what happens. Bless you. Okay, if it works, it works. If it doesn't, you fix and run again. So euro is equal to euro and L, right? And I'm going to go in there. I'm going to run this thing. It's going to ask me how many times do I want to repeat? 4 times, all right? And here's a 0 to stop this thing. So it goes euro is equal to 1, 11, 21, 31, 41, all the way to 91, right? It doesn't go exactly to 100, right? I could fix it if I want to, right? Why don't I go and I make my euro is equal to 0, right? Run it again. 0, 0, right? So now it goes 0, 10, 20, 30, 40, etc. to 100. Okay, so that's the first step. And then the next thing that I want to do is next to the euro, maybe I should make a variable dollar. Right? So what kind of a variable should the dollar be? Should it be a decimal number or a whole number? Decimal number. So I'm going to make it a, let's say a double. Double USD. That's a dollar. Okay? And then in here, in the beginning of my loop, what I'm going to do is I'm going to tell it, all right, well, the US dollar is equal to the euro times 1.19. Right? Because that was the conversion. Okay? So I go in there and I'm going to go and I'm going to do another label. USD equals, maybe a little space in there, comma, is equal to the USD and L. Alright, so I run it again. 0, 0. Alright, and there you go. So 0 euros are $0, 10 euros are $11.9, etc., etc., etc. So that's one thing. So one thing I can do is I can get rid of these labels. So I don't want to see euro like right next to each other, right next to these numbers. I want to put the euro on top. Right? So I want to have a label on top that says euro and then another label that says USD. Right? So how do I do that? I take out, C out, I put this piece here, and then I get the USD. I put that here. Oops. Okay, so that's one way, and we're going to do an endl. Then I'm going to get rid of this piece here. I'm going to put a little space in between these two values. How much space? Why don't I copy this piece here? That much space in between the two values, and erase this. Let's look how this works. All right, 0, 0. All right. So this is the euro, this is the US dollar. Notice something happens though. So when I have 0 digits here, this is here. When I get to 2 digits, this column gets pushed by 1 to the right. Right? And then when I get to 3 digits, this also gets pushed 1 to the right. Right? So I don't want to see that. Right? So how do we do this? Let me look at the actual assignment. If I put some information in there, yeah. So you have to, there's two ways to do it. One way is to say, you have to include IO manip, and you have to say left set W, so why don't we go with that? So I'm going to go in there. I have to include, we're not going to do the time this time because we're not doing random numbers. IO manip, IO manip, right? And then I'm going to tell it right here. I'm going to tell it set W. Let's see how it goes. It's left set W. So left set W 3. So what I'm telling with this, it with this is reserve 3 spaces for whatever number we're going to show. Right? So even though I'm showing this here, which is a single digit, I'm going to reserve 3 spaces for it. Okay, even though I'm showing this here as 2 digits, I'm still going to reserve 3 spaces for it, and that will make my column here, this column, be all lined up, hopefully. So let's try again. And you see, now it's all lined up. And maybe I want to shift this a little bit to the left. All right, so move 1 to the left. Run it again, and 0, 0, and now it's all lined up, right? These are my euros under, and these are my dollars under. Any questions? There's another way to do this with the C++ notation, with the C notation, which is using printf, right? That's one way to do it. So for the printf, I have to include iostream, include IO, no, not iostream, stdio.h. Okay, so this is need this for printf. Okay, and I need this for set w. Okay, and I need this need this for cout cn. Okay, let me copy this, and that's the same thing. That's the same reason I need this here. Okay, so now let me show you how to do the thing with the printf. So I'm going to grab the printf, and I personally like the printf better. Printf exists in Java, printf exists in C and C++, and Python is very similar. It's basically almost the same thing as Python. Okay, slight difference. So what I'm going to do is I'm going to take this out. Right, so we already know this works. And I'm going to do this. I'm going to do a printf, right, parentheses, and first I'm going to put some quotes, and then after the quotes, so in here I'm going to do, let me just copy this space. This space is going to be right there. Okay, so what am I going to be inserting here? The first one is the euro, which is $, which is a %i. Let's try %3i. And then after it, I'm going to say %.2f. Okay, and then in here I'm going to do the euro, and then I'm going to do USD. And do I need a comma? I need a comma. There you go. Now it's happy. Okay, so let's hope it works. Do not call CSTAV or whatever. Okay, so let's try to see if this thing works. Keep your fingers crossed. So, same thing. Whoops, I forgot to do a new line. All right, so it's putting everything on the same line. How do I do a new line? \n, and the whole thing. All right, run again. 0, 0, and there you go. Okay. So it still reserves 3 digits for this. It lines them up to the right. Okay. If I want to line them up to the left, I think the minus goes here. I think it's there. 0, 0, and now it's lined up to the left. It's still reserving 3 digits for every one of these that I show here. All right. So let me put a little comment. So %3i, let me erase this. %3i means insert the integer euro here, reserving 3 spaces for it. Okay, and what the %2f does, %.2f means insert the double USD here, reserving or rounding it to 2 decimal digits. Yes? All right. By the way, leaving the class early is a good recipe for failing my class. Okay, just so you know. And I'm only saying it because some people have already done it. So let's see. Next one is your P21. So any questions on 19? 2 different ways you can do it: cout or printf. I personally like the printf. It's less typing, right? So this is the cout. You have to do a whole bunch of things. But whenever I want to format something, okay, use a printf. And for the printf, you have to include the stdio.h. Okay? So next one is P21. Let's have a look at 21. All right. So 21 has to do with ASCII, and we already had to do a little bit of ASCII. Remember, we had an assignment where you had to do ask the user to enter a number or upper or lowercase letter or something else, and then based on their inputs, tell them what they entered. Is it a number? Is it uppercase, lowercase letter? Okay, we're going to use the same thing to show these characters, right? So we're going to start from the exclamation, and we're going to go all the way down to the tilde. So where's the exclamation in this chart? The exclamation is 33, right? Exclamation is 33, and if I go in there, and the tilde is 126. So what I have to do is I have to show you characters from 33 to all the way to 126. Let's do this. So I'm not going to show all of them. So let's say I want to show the numbers. I want to show the numbers, only the numbers. So 0 through 9 which is ASCII characters from 48 to 57. Okay, 48 through 57. So this is P21, hint. All right, so I want to show the, well, let's do letters. I'm going to do letters, uppercase letters from A to S, and I want to show them 4 per line. I want to show the letters A through S showing 4 per line. Okay, so next one, I go in there, and is this going to be a for loop or while loop? For loop, right? I know where it starts. It starts at the A, and I know where it ends. It ends at the S, and I'm going to show every one of them in between. So what's the letter A? Letter A is 65, and letter S is 83. So from 65 to 83. So let me put a little letter. So this is from for loop 65 through 83, right? So I go for int, let's call it ASCII, is equal to 65. ASCII is less than or equal to 83, and then ASCII plus plus. Okay, first thing, let me see if it shows me these numbers from 65 through 83. So cout ASCII equals ASCII, all right, and and run this thing, hope for the best. 0, 0, all right. So 65, we got the 65. 83, we got the 83. Okay, so then the next thing I'm going to do is, instead of doing this here, I'm going to do a cout char ASCII. So what I'm telling it is, I'm telling it convert. Damn it, it crashed again on me. Damn. Alright, I gotta update it or something. This is 3 more crashes than ever. Reopen. It really throws me off when it crashes on me. Alright, it saved it that far. Okay, so the next thing I'm going to do is I'm going to take this out. I'm going to do cout char ASCII and save. Run this thing again. And again, I have to go and enter some stuff. All right, so now it shows you the letters A down to S, right? Okay, so now the next thing is, what I'm going to do is I have to show them, how many did I say? I said 4 per line. Okay, so what I'm going to do is I'm going to get rid of the endl. All right, get rid of the endl, run it. 0, 0, right? Now it shows them all on the same line. Okay, maybe I want to add a little space. A little space in between. Run it again. 0, 0. That. Okay? So now what I got to do is, next thing is, I have to count every letter shown. Right? This here shows a letter. Alright, so count every letter shown. And by the way, there's different ways to do this, but I'm just going to go with the count because it's easier. Okay, count every letter shown, and if you count 4, show a new line. So I'm going to make a variable count, int count. I'm going to make it equal to 0 initially. Every time I show a letter, I said I'm going to count that thing. So count plus plus. All right, that's this. And then if my count becomes equal to 4, I'm going to do a new line. Cout endl. All right, and let's see how that works. So I run it again. All right, whatever. And it shows, it works fine for the first 4 letters. Okay, but then it doesn't. Why is that? Huh? Send it back to 0. Okay, so if it starts at 0, I count every character shown. So when I show this one, it's 1. Then when I show this, count is 2. When I show this, count is 3. When I show this one, count is 4. As soon as I get to 4, I show a new line. Then I show the next one, count is 5. Then it's 6. Then it's 7. Then it's 8. It never goes back to 4. So how am I going to do this? Well, I'm going to have to add these curly brackets because I'm going to have more than a new line in there. And I'm going to do count is equal to 0. Okay? So I'm restarting counting. Restart counting. So I run it again. And 0, 0. And there you go. 4 per line. Any questions? We got it? Okay. So that's that one. Save this thing. It's already saved. Okay. So next one is sum of numbers from 150 to 250. All right. I pretty much give you the example in there, right? So I'm not going to go too much in detail in this. Maybe I should even put a picture in there so you don't copy paste it, but whatever. So the way we sum things is you make a variable sum equal to 0. And then what you're going to do is you're going to be, and this is an example that sums the numbers from 10 to 20, right? So the first time we go through the loop, sum is equal to its old value, which is 0 plus 10. Next time we go through the loop, sum is equal to its old value, which is 10, plus the new one, which is 11, etc., etc., etc. And that's your sum from 10 to 20. Questions? Make sense? I hope so. Okay, next one, 23. This one is counting the numbers, how many numbers are odd or even. Okay, so first of all, this is write a program that accepts integers from the user and tells how many of the numbers entered were odd and how many were even. The program should stop asking for integers when the user inputs 0. Okay, so I guess, where is this thing here? This is your hint for P20, this is P23 hint. Alright, because you have something that stops at 0. The only other thing that you have to do in there is you have to count odds and evens. Alright, so I'm going to say something like int count even, right? It's equal to 0. And if my value modulus 2 is equal to 0, then I'm going to count it as even. Count even plus plus. Okay, and then you show how many of these evens you have at the end of the loop. Okay, so that's that. So count the odds and the evens. Any questions? Still good? Okay, go next. Largest, smallest, sum, and average. Okay. So, how does this go? Write a program to find the largest, smallest sum and average of X numbers entered by the user. The program will prompt the user to enter X and X numbers, pressing the enter key after each number entered. All right. So we're going to ask the user how many. That's pretty much this here. All right. I'll do it for you again. 24. Okay. So this is P24 hint. P24 hint. So find smallest of X numbers. Right? So int X is the user. User decides this. How many numbers would you like to enter? That's my X. Cn X. And that's going to determine my loop. Is it going to be a for loop or a while loop? For. I know how many times it's going to happen. X times. So int, I don't know, k. For int k is equal to 0. K is less than x. K plus plus. And I can ask the user to now enter some kind of a value. Let's call it num. Okay. Cout. Enter a value. Okay. Cn num. Okay. And the way it's going to go is this. So there's an algorithm to finding smallest, and it's similar to how we're going to find largest also. Okay? So what we're going to do is, and by the way, 23 shows you how to do the sum, so I'm not going to do the sum and average and all that stuff. Or we're not going to do, does this thing ask for average? Yeah, it asks for average. Okay. And what the hell, I'll do a sum. So sum equals 0. Okay, so as soon as they enter a value, right, I'm going to say sum is equal to sum plus that number. Right, this is add up all the values that the user is going to enter. And then to find the smallest, right, this is going to be my algorithm to find the smallest. Algorithm to find smallest. Okay, it's going to go like this, like this. So make, and I should make a variable smallest somewhere in there. So let's call it smallest. Okay, so make smallest equal to the first number entered. Okay, and then compare smallest to every other number after the first, and if any other number is smaller, that is your new smallest. Okay, so let's say, suppose you have these numbers like 4, 3, 2, 1. Okay, these are my numbers that the user is going to enter. The user wants to enter 4 numbers. These are going to be the numbers in that particular order. Okay, the first thing that I'm going to do is I'm going to say smallest is equal to 4 initially, right? Make smallest equal to the first number. Okay, if I can spell it. And then the next thing I'm going to do is I'm going to compare smallest against all the other numbers. Okay, so if any other number is smaller, that's your new smallest, right? If any other number is smallest, that is your new smallest. Okay, so it goes like this. I'm going to go and compare if my smallest is, or if the next number, if 3 is less than smallest, then I'm going to say smallest is equal to 3, right? And then I go to the next one. So basically, initially smallest is 4. I'm comparing it against this. Is this smaller than smallest? Yes, it is. So now smallest is 3. Okay, the next one is going to be, all right, so now if 2 is less than smallest, then smallest is equal to 2. So it was 3. I'm comparing it against the 2. The 2 is smaller. So now smallest is equal to that one. Then I go to the next one. And if my 1 is less than smallest, then smallest is equal to 1. Yes? That's the logic. Okay. So I guess the only trick here is, how am I going to make smallest equal to the first number? So my question is, how do I know if num is the first number entered? There you go, right? So k starts at 0 initially, right? So when it is 0, that would be the first time I enter a number is when k is equal to 0, right? K equals 0 for the first number. So if my k is equal to 0, then num is equal to, smallest is equal to num. Okay? And then the next, so that's the first one. So that's the first piece. I did this now. So then compare smallest to every other number after the first. What will be the every other number after the first? Just an else, right? So this else here is, right, happens automatically for every other number after the first. Okay, so else, I'm going to check if, let's throw some curly brackets. right? So if my any other number is less than my smallest, then smallest is equal to that number. And that's it. Any questions? That's the algorithm for finding the smallest. All right? And I can show it to you after that if you don't believe it, but I won't. You better believe it. Okay? See out. I'm kidding. Smallest is equal to smallest. Okay? I'm supremely confident that this is going to work. So I'm not going to test it for you. Okay? Take my word for it. So that's that. And then, is there anything else? 25, average, largest, smallest. So there's another one. This one is similar to the other one, except we don't know how many numbers are going to be the user is going to be entering, right? So how is it going to work? Well, you have a while true, like I told you, and the loop is going to stop when the user enters a negative 999, right? And this is pretty much your little hint in there. I give you more than enough. The only thing that I haven't shown you is how to find average. So the average, C out, average is equal to my sum divided by what? Total or X, right? And del. And that's it. Okay? So you know how to find if a number is even or odd. You know how to look for a smallest or largest. And by the way, for largest, what are you going to do? Just flip this around. If a number is bigger than largest, then largest is equal to that number. If a number is less than smallest, then smallest is equal to that number. Okay? And we're going to do this kind of stuff when we get to sorting. When we get to arrays, which is lists of numbers, I'm going to show you how to sort them using this kind of a very similar algorithm. Okay, so I think that's about it. Let's double check. There's nothing else. This is 25. Oh, there's another one. Damn, 26. Hold on. I thought it was the last one. Come on. Almost done, almost done. No, number guessing thing is next week. Okay, so now you have hints for 19 through 25. And that should be more than enough. I have all these things here summarized in separate links. I have the old lecture. I have the old video from the summer. I have the chapter 3 Savage, which talks about ifs and elses and whiles and all that good stuff in many, many more pages than I think is needed, but read through it. And there's going to be maybe a little quiz in there coming up pretty soon for chapter 3. So that's all I have for today. If you have any questions, email them to me. Don't wait. Come see me. My office hours are posted. And then again, remember, if you need extra help, STEM, Gavilan, STEM Center, all right, go see them. And I will post the tutor's specific hours. And it's usually she's there in the morning, like from 9:30 to 10 or 11. So that's all. Yeah, thanks for coming. Hope to see you next time. And let me know if you need help.